which could have probably been guessed based on us ending there yesterday. Did we even really get to the got it at all, or did we just totally not even touch it?
How do you? Caleb.
We just didn't touch it all. Okay, so that was all you guys. That wasn't even me. So let's see if we remember what we did yesterday. So check out this got it on the back, 14.4. All right. So we've got a population of sparrows, and in city C, we use the function c of x. City D, we use the function d of x. What is the function giving the difference in the population of the sparrows between city C and city D? Do we know which one's going to have more?
Well, what has bigger numbers? That's math right there.
Well, so 1, what type of function is c of x? Hey, Caleb, can you find a seat somewhere appropriate?
He's not.
What sort of function is c of x? Caleb?
Is that an exponential function?
It is exponential. We have our coefficient, our base, and then a little, almost like a linear piece of it. And then we have function d of x, which is linear. So we could, if you want to start out and figure out which one is going to have more after 6 years, we could either find out the function values after 6 years, or we could graph them and look at which graph is higher, because we'll be able to tell one is linear, one is exponential. Or we could just take the difference and do what? Yeah?
Absolute value.
Yeah, if it ends up negative, we can just absolute value it, or that'll actually tell us which one's more. So let's just make a guess which one we think will be more. Which behavior, guys, can we stop? You're literally ripping a pencil apart to throw pieces at him. Would you like to go get the vacuum cleaner and vacuum the entire pod? Because that seems like an appropriate punishment for not caring about the trash you're putting on the floor. No, that's not what I asked. If you're going to throw trash on the floor of the school, would you like to be the person to clean the school? Then stop. I really feel like I don't need to be having this conversation with an 8th grader. Can you respect the fact that I have 45 minutes with you guys and I would like to get through some stuff? And once we finish our graded course of study, we have cool stuff to do after that. Keep moving forward.
Wait, how many years are there?
15. We were just talking about that at the beginning of class. This is the end of chapter 14 today, and 15 has like 5 sections. And it's quick. It's arithmetic and geometric sequences and
Why do they
series.
have 15?
Oh, those
so
are
like
boring.
Because they just made it 15 sections. How much content they wanted to cover. Really, they should have made it more because chapter 12 should have been broken up. Carmen.
Can I say this?
Yeah, so back to the question I had asked was which of these do we expect to be greater after the 6 years?
I think. Oh, after the 6 years?
Yeah,
Oh.
we just have to make a guess to set up our difference.
I was
function.
thinking just like in general, kind of like if you put like, I was kind of thinking like if you put 1 in for x, like the c of x would be like larger.
Okay, but let's just make a guess. After 6 years, would the linear, the exponential? I mean, we could compute it, but we don't want to take too much time. We just got to set this up and figure out how to
Then
get it.
I would probably say that d of x.
D of x, sure. So if you want to set up, and we can make some name of the function, or we could just say we're going to do d of x minus c of x. And we could actually say that this is d minus c of x. And then we would put that d minus c in parentheses. So to set that up, we're going to take our function d of x. And I'm just going to call this f of x now, since they haven't used f. Just to make our life easier, let's call this f of x. Is going to be the 500x minus 600 minus 950 times the 1.29 to the x Remember, we can only combine like terms. So start to identify what things are here that won't have any like terms to combine with. And then we can just figure out what their value is and kind of move them out of the way. Ethan, you just stretching.
Yeah.
Caleb?
The only thing that doesn't have a like, at least in terms of the only thing that doesn't have a like term is the 1.29 to RX.
There's also another piece to that, though.
Yeah.
This has
Oh,
to
yeah.
stay attached.
Oh, okay, so 950.
So this does not, I guess I'll change colors again. This does not have anything to join up with it. So let's go ahead and put that at the
Yeah.
front.
Oh, and then also we negative 600 is right.
So also the constant from the first one. But if we want to put these in order, let's throw the exponential value at the front. And then we'll put our x value. And then we'll put our constant value. So we're now going to set up that f of x is going to be that negative 950 times 1.29 to the x. Then if we think about combining our x values, when this distributes, that x value actually becomes positive. So we end up with positive 620x. And then our constant portion stays negative. So that's going to be our function modeling the difference between them. We input 6. We can figure out the difference between them. So for f of 6, we end up getting. This is going to take just a moment. Now, honestly, if you're working with a... Oh, by the way, does somebody have one of the graphing calculators at home with you?
Yeah.
Okay.
Oh, I know.
Well, okay, with you, like in your possession. If you have a graphing calculator, the easiest way to do this is type this into a y equals and then evaluate it at 6. So if we type in, if you want to work along with us, 950 times 1.29 to the x.
Oh.
Check that you can actually put it.
It would also just work out if you solved it arithmetically, arithmetic, whatever we'll call it.
Yeah, you just plugged in each 6 and
Yeah,
found
that would
each
also-
little piece. Yes. But a lot of times this will then say predict after 6 years, 10 years, 15 years.
Okay.
Like you don't want to run it multiple times. If you type it into your y equals, you never have to type it again.
Is there a way to make your calculator find certain values? Like, I want to find the value of when x equals...
Yeah, that's what we're about to do. We're going to use the table.
Yeah.
So 950 times 1.29 to the x. You can put that whole thing in parentheses if you're like me and you just love lots of parentheses. Then, I know, right?
Wait, if it's in
Plus-
parentheses, wouldn't it put the 950 to the x too?
So I'm putting parentheses. Where's my other one? I'm putting parentheses here, is what I'm saying. Just to make sure that stays grouped together with nothing else jumbling in with it. Then saying plus 620x minus 620. So now hit second window to go to table set. What? Can we talk about the math and not like my behaviorisms or whatever?
Oh no, she was talking about the sign behind you.
Okay.
She wasn't pointing at you.
That one that's falling down.
No,
Okay.
okay.
In your calculator, hope you're working with me. When we hit second window, we are now in the table setup options. What do we need to change here? Or what do we need to check? Caleb?
Would it be the independent ask?
Independent has to be asked.
Where are we? In the calc?
Second window to go to your table setup.
Oh, okay.
You don't. So then we'll go into our table. So you'll hit second graph to go to table. Then you can input whatever x you want. So when we input x of 6 and hit enter, we get our output. Like 7,000.
That's what you got? I got 7,400.
Okay.
I got 1,000.
That's what I got. I did it. I agree with you. What'd you get?
I got 1,000. You didn't take negative 950? Is it a negative 950? Nope.
Ah, it is.
Oh.
We dropped that negative because when I looked at the equal sign, we missed that.
See, Brian?
Forgetting that negative causes bridges to fall down and causes me to have the wrong answer. So really, what's good though is you wouldn't even see that in the video probably because it's covered up by the video screen. Really, it's a negative, and this is kind of what I anticipated to happen. By getting a negative difference here, what's that actually tell me based on our setup?
You flipped them.
We anticipated the wrong city to have more because we just did city D, or population D, minus population C. So really what our results tell us is C has more after 6 years by 1,258. Because our difference was negative and we were anticipating D having more, we were wrong. C has more. Doesn't matter because we can still use that information. Probably. Any questions? Sorry, be careful with that negative that we dropped. This right, that's fine, blame me. This negative right here, totally my fault.
Wait,
I
do
did
you
not
have the
write that.
negative outside the
No,
parentheses?
it should not, like, that's, I drew that. I don't know if I can drag these things. Nah, it's all stuck together. So, if I could drag the parenthesis to
Yeah, I was gonna say
here, yeah, something like that.
Yeah.
Found it.
Cool. We all get negative 1258.
I need to show you.
So now, yesterday, we got stuck. And for good reason, really.
Yeah, I saw your school comment.
But it kind of made me really nervous, because we set up that. And the question we posed was, okay, so what do we do with that? Where do we go? And we were all just kind of like,
Well, Calvin was saying foil, and I thought that was the answer, but I don't know.
So what do you mean by that? That like,
When I say foil, you put every what are they called?
so are you numerator?
Well,
Or
you put
piece?
every
Are you
number
saying-
over every other number. No.
You're saying do this, then with only the 2x, and then that only with the 3?
No, wouldn't you do the 4x and 7,
Oh,
4x?
I'm asking
Each
what he's...
individual term with
Yeah.
each other individual.
So it's like
Hmm.
4x negative 2x, 4x
And then you get
negative
4x.
Yeah,
7.
and
That's
three,
what I
So you're
Yes,
hypothesizing do 4x over 2x plus 4x over negative 7.
You need a math.
Yeah. That's what I did, and then I mapped myself into a corner.
You mathed yourself into a corner, because then we got 2... I had this stuff written on Post-its, and then I threw it away, because I was playing with all the possible options that end up with wrong answers.
Would it be 2x?
No, because
No,
x
I'm
is
not
canceled.
getting the entire day. I will let it sit there for days. No, you better get it.
Oh,
I threw a tizzy.
man, that was
What is it?
You're not using words.
it's
Yeah.
Wouldn't you
like simplify the 4x plus 3 over 2x minus 7, and then
Well, that's what we're asking. Is how could it, like, can it be simplified?
well,
And if so, how?
wouldn't you do the thing? I don't know the name of it, but
Hey guys, we got way too many side conversations because I doubt that any of you definitively could tell me exactly what we should do for this. Like if on the state test it said, what can be done with this division, this quotient?
I have a question.
So, Lynn was in the middle of asking the question. You're unaware of that because of all the side conversations. Sorry, continue.
so you take the like terms and you like subtract them or add them so that they're on the same thing. I don't know what it's called.
You're talking about like we could do anything we want to the top and bottom as long as we do it to both, because then we'd be like multiplying by 1 or dividing by 1 or whatever.
Well, we could put plus 3 and negative 7 together to make like negative 4.
But we can't because they're split. So this plus 3 is tied to the 4x through arithmetic. This 7's tied with the 2x with subtraction. We don't know what the numerator is without knowing what x is. We don't know what the denominator is without knowing what x is. And we can't do division until we evaluate the numerator or the denominator. Well, really both. Megan?
Could you multiply the top by 2x minus 7? To get rid of the
Would.
2x minus 7 on the bottom?
So this really doesn't work.
Okay.
Like you said, it maths you into a corner. There are some ways that we can play with, like, what could we actually do here, but it doesn't really work. This comes out to give us, like, 1 4/7. What was my answer yesterday? It was negative 8 plus 21. It was like a positive 13/14 x. This is not what we want to work
We
with.
got
And this
nine.
won't get you the right answer.
We got 3, like.
Yeah, because when we plugged in 12, we got 3. Pretty easy to find it when we plugged in 12.
I have a question.
Yeah.
What kind of function would this be? Because I put it into the calculator and it gave me a really weird graph.
This is really just kind of like the understanding what we're doing sort of thing. So it's hard, I don't know exactly how to relate this with. So it'd be the like unit rate of whatever F represents divided by G. So if F is sodas sold and G was patrons at the game, then this function would be solving sodas per patron. It's hard without knowing where the function came from. But a quotient function would be showing like a unit rate sort of situation.
This graph is really weird.
Yeah. So this is your quotient function. You're fine to leave it here. We really don't want to do anything with this because the arithmetic in the numerator and the denominator stops us where we're at. What you're thinking of when we can simplify pieces and parts is when there's multiplication or division in the numerator or the denominator. Like if we had 4x plus 3 times something up here or times something down here. But yeah, the only thing, I forget who said, the only thing that we could do with this to simplify it a little bit is try to get rid of that 2x minus 7, try to simplify and get it like over 1. But still, we're still going to end up with some variable values, some constant values, so we could just leave it right like this. Now, you were saying we could potentially do, what would you want to do?
Either multiply. Couldn't you add the
Reciprocal what?
of the bottom?
So we
Couldn't
can't
you?
add. We can multiply or divide by a value of 1.
Division wouldn't. You couldn't just divide the top and bottom both by 2x/7 because that would just put you in the same column.
Which is exactly what I'm trying to get. Well, no matter what we do, we'll just loop back to still having a quotient of functions. We might manipulate this a little bit. Like I could double the numerator and denominator. And I could say, well, what about 8x plus 6 over 4x minus 14? Well, it's the same function. So what I'm trying to get you to see is we're done. Right here. This is, look, we're done. When there's addition and subtraction going on in the numerator denominator, you might be able to manipulate it a little bit, but there's no reason to. You'll leave it like that. That's your function that you would type into your calculator. Crowley?
Couldn't you multiply by 2x minus 7 and just distribute that?
That's what Megan said.
We can, but still, like, it's not gonna. So let's play with what that would do.
Okay.
So, if you
Okay, you have to point.
multiply by 2x minus 7,
And then you FOIL both of them by the same amount.
okay,
Which will put you in the same spot.
Oh, because it went in. Oh, okay.
essentially,
Oriana, please come to the office.
one
Oriana.
of these could cancel with one of these, and you end up in the same spot. Because all you're doing is multiplying by 1. So again, what you're getting kind of confused on is if there was a multiplication or division, or if we could factor the numerator and or the denominator. So what I posted on Schoology was an example of when we can deal with things like that.
I got really worried when I saw the little notification that said, "This is concerning," and I was like,
Yeah, I was like, wait, what?
"Did
So-
someone do something?"
Con, and I'm not going to unplug my stuff to play it off. But if we had two quadratic functions, let's say instead of having two linear functions, we have two quadratic functions. And we wanted to evaluate their quotient function. So we set up the one quadratic over the other. We then look at, well, how can these quadratics be looked at differently? Because I don't want to change what I have, but I can change what it looks like. So we look at can I evaluate this and factor it out? Well, you guys know how to factor, so we're looking for, we need values that'll multiply to the 2x squared, and then constant values that'll multiply to the negative 8. We figure out that if we make this 16 minus x, we can get a 16 with the 8 and the 2x. And then the minus x we can deal with in the middle. So without doing too much review for factoring, we can factor this out to be this. 2x minus 1 times 8 plus x. We can then do the same for the denominator, factor it out. We found out it's x plus 2 over x plus 8. Anyone got an idea what we get to do here now?
Math. X plus 8.
The x plus 8s are going to cancel. Because we've now found common factors in the numerator and the denominator, so now I can divide both the numerator and denominator by x plus 8. And when I do that, I end up, as long as x is an 8 is what that tells me. So we actually need to go back to the function that we were just talking about and realize there is a domain restriction now. So when we end up with a quotient of functions, there will be a domain restriction based on one very important mathematical rule. Why is he saying that x cannot be negative 8 here?
I can't even see what he's doing.
Yeah.
Yeah, it's like way too dark.
White.
I can barely see the bottom still.
What?
That's
Oh,
true.
actually.
The purple.
Where did the x not able to equal negative 8 come from? It's actually in the text right here, ironically.
Because it's not defined when x equals negative
What causes something to be undefined?
8 if it's flat. Or
0.
Well,
What about 0?
When it's divided.
Oh, it's divided.
Division by 0. What else couldn't x be? 2.
Really?
Wait, she being serious?
negative.
Yeah, sorry, was it negative 2? Negative 2.
Wait, what?
Wait, is she being serious?
I didn't know.
Because either of those would make your denominator 0. So, once we get here, though, we're done. But once you get those linear functions stacked, there's nothing that can be factored out. There's no common terms that we could make simpler. If there was only one value in the denominator, then I can split the division. But we've got two values. We got a binomial in Carmen.
So what's the benefit of doing that since there is that restriction? Like,
It makes your function easier to look at. So
Just-
instead of having
okay.
a quadratic over a quadratic.
okay.
So here, we wouldn't have to, but this makes it a whole lot easier than looking at this.
But like, would you do that in like a real world situation?
Yeah, so like, I think it was Calvin asked, well, like, what would this be used to model? If f of x was amount of items and g of x was amount of people, what we're now looking at is items per person.
Yeah.
Or maybe it's like cars per hour. Or, like whatever you've got modeled,
Oh,
you're
yeah,
just
so
looking for a rate.
but it probably wouldn't be a restriction because you can have negative stuff.
Depends on the situation. Like
But, I mean,
that.
okay.
This is the mathematical restriction that we couldn't have 0 on the bottom, so we can't have a negative 8, and this x also can't be negative 2.
what would that be?
I have a question. So, if you were to graph this out, would there just be like a hole where negative 8 would be? So it
Skip
would
it.
just be going, and then just
Yeah. It literally like skips the point.
Oh.
Because the function is undefined there, so it has no function behavior since it's undefined.
Well, that seems like a. So wait, would it work with like -9, all of those afterwards?
So let's play with the one that Khan's got going on here. So I'm going to throw this up on the TV.
So makes sense why the graph looks so weird.
Right?
Yeah.
So if I graph 2x squared plus 15x minus 8. So here's his first parabola. His f of x. And where, what do you mean? I'm not graphing his simplified one, I'm graphing the original. So that's his original f of x. His original g of x, I'm just going to put a lot on this graph. X squared plus 10x plus 16. What do you notice? Caleb?
They look relatively similar, except the red one's a bit wider and it's been moved. Well, I guess both have been moved.
Where is this?
Oh, that's the point they share.
That's that -8. Here, that -2. The behavior that causes the denominator to equal 0, which causes the quotient function to be undefined.
Sweet.
So if I type in the quotient function of 2x minus 1 divided by x plus 2.
Oh, Lord.
Oh,
Lord.
Lord,
that's what
Lord.
happens when you
No, zoom out. It looks really cool with the graphing calculator.
That- And you'll learn more about this in Math 3.
How does it even
Anyone know what that vertical line right there would be called? Starts with an A.
Here's the symmetry.
No, yeah, asymptote.
It's the asymptote.
What?
So like
yeah.
A, S, Y, and P.
Yeah.
Yeah.
No swearing in school.
The best math term.
So, the asymptote is where the function cannot exist, and its behavior gets really screwy there too.
I have
Like,
a question.
It just, zips up and then all of a sudden comes from negative infinity back to the function behavior. So we also have a horizontal asymptote here.
That's weird.
So that horizontal is at, well, we can probably get real close. 2. Looks like it's probably 2.
Can I ask what -8 plays into this? 'Cause it looks like it doesn't do anything with this graph.
It will cause this to be undefined.
Well, yeah, but I'm saying, like, in this case with this graph,
Because we factored that out. When we look at the simplified quotient function, that -8 no longer has the control of the -2. That's why this asymptote is at -2.
okay.
Because we factored out that situation where the -8 really mattered.
Okay.
Wait,
Right here, sorry, up on the TV. That mattered with these values that we then got rid of. So actually, if you look at the simplified quotient function, now -8 doesn't cause anything to break.
I was just saying,
-8 can be plugged in.
thing.
But we know that before we unsimplified, we weren't allowed to use -8. So still we can't use -8, even though it looks like it'll be fine on the graph. And now we see we can't use -2, and the graph shows us that being the asymptote. Brian?
Is there a way to like predict how big the gap between the two graphs will be?
You mean like this?
Yeah.
This gap is infinitely small because it is only the amount of space where x equals -2. So it is only that exact point. So these have values as it gets infinitely close to -2, and then they have values as they start out on the positive side, infinitely close to -2, and then as they go towards their other more kind of tangible values, the behavior levels out.
So
It does what
basically,
you want
that
to.
-2 is like their no-no spot, so
Yeah.
you just can't go there.
Sure. Yep, it's the no-no spot.
It's a little square.
Then
It's their no-no.
So is this like visual proof that we wouldn't be able to simplify that?
it's like the green lines prove to us that -2 breaks our function because the behavior gets all messed up. So it makes our function undefined, which causes this to happen. You'll go deeper into this in Math 3, what we do with asymptotes and like why we use them. I just wanted you guys to see it. Cal?
What would happen if you graphed it with the x plus 8?
So, what's your prediction? Because if I do the same thing on the numerator as I do on the denominator,
It should be the same, but x plus 8 is now our thing.
Whoa, that had like
Nothing happened.
It's boring.
it's the same function because multiplying by 1 doesn't change anything.
But then it has the -8.
I know.
So we sometimes it shows it to us by the graph. Sometimes we have to know it because this can be factored out, and therefore the graph doesn't really visually show us that. But if I go back to the unsimplified form and I did this, divide it now. Desmos is really smart, but it does exactly what you're telling it to do. So, which is great until you do it wrong.
And then that's user error.
Same thing.
Okay, this is confusing to look at.
But
They're all the same. It's like when you simplify 4x over 2x and it's 2.
Wait, so
They're the same.
well,
Wait,
what's
so
the
the
value
low
when
is the same
it's
thing as
8?
yeah, then why do we have to?
So at -8, everything like, so here's your -8.
It has a value though.
These equal 0. So yes, it looks like it'll be okay, but that's like, this is where it gets way too complicated, and we haven't set up enough understanding. I don't want to go too deep into this because I would like to start checking chapter 14 homework. We only have like 9 minutes left. I just wanted you to see what those domain restrictions cause. They cause asymptotes. You don't have to understand that right now. You just have to understand you can't divide by 0.
How would that apply to like real world?
That would be a value of the function. Like maybe that's a year that doesn't exist, or
That
it's
just
some
seems
sort of
like-
restricting factor that it doesn't work with that input. It's hard without having physical values to write
Question.
that to. Yes.
Do you know who spent the time to figure that out?
Mathematicians.
No, yeah, but like the name of said person.
I mean, you can research it. I mean,
But I feel like
things
I feel
are
like
attributed
all
to
that
many
work-
different mathematicians. A lot of times there were multiple people working on the same stuff at the same time.
Yeah, but I feel like all
What
that work.
is our restricting factor here? If we go back to just
Kids drop out.
ooh, close.
-7 and 2.
It's like, okay.
What can't x be?
7 -2.
7 halves.
Well, okay.
You got it, Brian. I'll look.
It's 2 divided. Close.
You don't need to worry about it.
7 divided by 2.
So x cannot equal 7 halves. Because if I plug in 7 halves, I'm gonna get 0 in the denominator. Really, that's 3.5. But yeah, Megan.
Okay, did you buy that sign with the intention of putting the mathematical stuff on it, the caution? Or did you just like get it and then you were like, like, did you just buy it with that